Hello, everyone.
Hello.
Hey, good morning.
Morning.
Morning. Reddy is not able to join today's meeting, so I'm going to host. We don't have um, a presentation today. Um, so from the agenda, it's just open discussion for the white paper. And for next week, we'll have XCon to present their Fabric Manager API. If there's any other companies Fabric, any other company that has their Fabric management system, we might reach out to invite them to give us a talk. Uh, is is there any company in your mind that might potentially present here? Let me see. We have okay. Yeah, looks like we don't have a lot of attendees here today. Um, okay. So how about we just see if anything you would like to bring up for the white paper. Uh, if uh,
Yeah, so I mean, a few things that I think we can talk about here. So, this is this is the CMS group, not the CXL group, right?
right.
So like CXL does have a fabric management API, right? And that's for talking to stuff and creating VCSs and blah blah blah. And that's a little bit different than how we've been talking about fabric management here in this group. So maybe a good section would be um, memory fabric management and how that interfaces with the various memory fabric managers, right? Like helping people to understand that um, some protocols and standards may have a way to do that management, but like this group is interested in a superset so that everybody who has their own fabric specific management layer can just sort of like plug in, and this can sort of be like VFIO for memory fabrics, right? That might be a useful section in this white paper.
Grant, if I may, it is true that we've been trying to be broader than what only CXL is for memory fabrics in this meeting. But CXL is out there. It's very clearly defined and such, and people are building things to it. So wouldn't it make sense for us to figure out how to do Fabric Manager using CXL methods? And then
Oh,
any other fabric will just check it. Hey, did we cover it correctly or not? If not, then we add to it as a separate item. So people have POCs and devices to just go play right now.
no, we're aligned. Yeah, no, essentially what I'm saying here is that like um, there's only so many ways to do things, right? And so like I think that CXL has hashed out pretty well what fabric management looks like. And I think what we need to talk about here is like if you wanted to just bolt some user facing application or some orchestrator to a fabric manager, like these are the primitives, but then these primitives happen to be tied pretty closely to CXL without a lot of indirect translation, just simply because CXL has it hashed out well. And then as you have stuff like Ultra Ethernet or UA Link or whatever, um, maybe come into prominence, it's sort of like a look, these are the primitives that people are expecting that don't have your verbiage in the call, and just plug in during this interface. That's sort of what I was talking about. But yeah, I mean, I think that CXL is a great plum for that. Is just, are the calls pretty much the same? Yes, they are pretty much the same, but the calls don't have CXL in them. The calls are just CMS memory fabric calls, right?
I think that's true, yeah.
I think another good section is talking about the difference between fabric management and fabric orchestration, so that we help damper down the conflation of those terms, right? That's probably something useful. And then we can sort of get into the details of like, look, you know, interfaces like Redfish and others are how you do the business of making sure that the fabric is healthy and correct, and all of the mechanisms of assigning stuff and linking stuff is sort of with the fabric manager, but the why of doing those operations is with an orchestrator. I think that's probably another good section to have for the white paper.
Yeah, good. Do we want to have a section talk about like the hardware definition? Yeah, like saying for system we have servers, we have CXL memory locally attached, switch attached, multi-headed, etc. Just have a chapter, make all the definitions clear.
Agree. Yeah.
Yeah. Well, it's just
Well, here's the disclaimer, everybody. We're going to be using these terms, and when we use these terms, this is what we mean. Yeah, I think that's a good idea.
I want to chime in. The topic too is really important, as we were discussing. In the past, separation between a single rooted and a multi-headed model has led to complete separation of technology stacks. Like I said, happened with InfiniBand versus Arapaho and PCI Express. So I don't know if there is a split here, but clearly systems that support memory as a resource for single host versus memory as a fabric resource with a fabric manager. These things haven't coexisted in the past. I don't know of a single technology, including PCI Express advanced switching, which failed when it was first introduced. There are lots of examples of failure, but no single example of a single technology addressing both needs. So I'm very interested to know what is the blueprint of success that you guys have in mind.
I think that's a good section for how orchestration and management coexist to provide a robust memory fabric to end users.
Well, the nirvana aspect of it is for us to work on ensuring that whatever composer management tools we create, as well as APIs, work with specific orchestration layers and are validated and tested under the kind of the guidance of this group, right? It really doesn't help if everybody goes and design their own path and their own API. the goal is that we try to ensure that not only that we architect APIs correctly, but we also validate them within this umbrella.
Mm-hmm.
I think it also has to do with coexistence of operating systems and fabric managers, and how memory management has a mother may I relationship with the operating system, because memory is in a device model. So with Fabric and memory as a fabric resource, it wants to move to memory as a service model, but we don't have good blueprints for success in using memory as a fabric resource. So two or three things that VMware has done are about the only things I know. And we need to study them and see if there is anything that we want to imitate.
Pankaj, perhaps to address your question, we can do a little bit of a divide and conquer. You're very correct in that to implement the full stack of sharing and fabric attached memory for the sake of sharing across multiple hosts, that's really hard and tall order. Within CXL, we have taken small steps. First, articulated memory expansion. That's simple. One host, more memory. Deal with it. It's lower latency. It's a little more latency, but it's understood. Then we did the memory pooling, which means at the beginning things are complicated, but once Fabric Manager comes and subdivides the system and assigns memory to different hosts, from then on, everything just looks like a single rooted entity, and everybody knows how to do that. So stitching before Fabric Manager is done to after Fabric Manager is done, we just load the OS. That is the part we need to do. Otherwise, after that is easy. The third one is the hardest one, and I think that's what you're touching on, is the shared memory. And then for shared memory, yeah, we need to do a lot of work. Is it coherence done by software, by hardware? How do you enumerate things? How do you manage things? What is the security? All of that is work in front of us.
Yeah, good characterization. Yeah.
Agree. Well, so I think that, maybe section 6 is, I just wanted to get this out, and then I have a section 7 too. Like section 6 is what's been done so far, right? Just a recap of like what's been put out in the wild from fabric management and orchestration. But then 7 is what you both were talking about, was, the warts, right? This is talking about like we as a group understand that there are UEFI issues and there are firmware issues, and OSs handle devices differently, and there's stuff that shows up as a NUMA node as opposed to stuff that shows up as a DAX device, and right. Even just like attaching a device to the server, and then because the server was so blitzed at the time that it was given this quote unquote removable memory, it pushed a kernel page there, right? It's not removable anymore until other stuff happened. Like section 7 is where we could really get into like, okay, we gave you a grand and glorious future on some of the work that happened, but we're also understanding of all of the challenges that are in front of what we talked about, right? Like that's probably a good way to end the white paper. It's just like a call to action on all the various things that still need refinement.
I really like a paper that Microsoft did, harvesting unused memory resources from cloud servers to offer basically a pooled memory but instead of implementing pooled memory using CXL devices, they just used unused memory from servers to construct the physical basis of that pooled memory. And they ran extra VMs on every server that collectively delivered extra memory to database servers like SQL Server and other applications. Okay. So when you look at their API, it was in 3 levels. First level was very simple, allocation and deallocation, like Grant, you were describing, Siamak also mentioned. Second level was interesting that they described pointer allocation and pointer dereferencing, because that is cognizant of memory at a distance, and you don't want to be doing that willy-nilly on this kind of memory resource. The third level was even more interesting and was completely motivated by actually applications trying to use a pooled memory resource. It had 2 APIs. One was called dflow and one was called fflow, which is how do we, what kind of operations do we offload to such things? Because load store API for such thing is not enough for doing the data functions. So I found that that blueprint actually matched what was done at VMware in the past, and also was similar to what Google did with ZSwap and TMTS in their APIs, in their published APIs. And I think that theme repeats. And when I said blueprint for success, what I'm thinking is, a progression of API elements that enable memory at a distance in a way that you can use more and more of CXL features. The other comment I'll make quickly while I'm speaking is CXL needs to be very clear about its role as either a scale-up technology or scale-out technology. It's still, to this date, it is very confused about where it lives. And so it's kind of not being explicit in what model it is in and what model it is delivering to. And that has caused a lot of confusion about its applicability and its completeness as a solution. So I think part of, unfortunately, we don't want to solve the world problems in a fabric management working group, but just being cognizant of the fact that there is lack of clarity, and concepts like fabric managers are more appropriate for scale out rather than scale up. But concepts like shared memory are very scale up concepts. So how do you marry these two? What is the clear thinking that will form the basis for the nouns and verbs of APIs and architecture? We need to make some concrete statements about the architecture.
Yeah, well, I mean, what you're talking about is how do you properly expose quality of service verbs to the end user, right? Because nobody's had to think about memory as tiers in recent memory, right? And so what we're talking about here is that it could be scale up or scale out, from the standpoint that scale up is I need more high performance memory for this one application, and scale out is I just need something better than NVMe for these things. And the end user hasn't ever needed to be responsible for understanding those qualities, because if the end user had been responsible for understanding those qualities, I think we'd have better software in general, right? And so what we're talking about here is there a set of semantics to an orchestrator that an end user or a resource allocator that the end user interacts with are general enough or verbose enough and straightforward enough to use that said entity would swallow them and adopt them into their software?
Yeah, I mean, yes, true, Grant, what you said. But let's think about, who has done this before. So if you look at HPE's Superdome and Dragonhawk systems. They were able to, scale up to very large, very high hundreds of CPUs, accessing shared resource, both attached to the CPUs and separate additional resource, right? And
Yes.
if you look at what are the differences between how they do things versus how CXL fabric managers are trying to do things, the first difference that stands out to you is membership. So memory systems, because memory is a resource whose failure or loss of contact causes kernel panic. One of the things that you realize about memory as a resource is it requires a very strict notion of membership. So once entities are pooling memory, they need to be where there is like I am alive or other messages going on. There is a certain requirement that failure of a fabric node in this case is like failure of a system component and leads to kernel shutdown or other nasty things. Okay, so you either hang your coat on evolved memory management, or if you stay with Linux, which is a pretty conventional memory management, loss of memory is pretty nasty. So that has to reflect in fabric management architecture, which I don't see. I mean, I just don't see that the fabric management software that is being written today is the quality that you see in the system software of a Superdome or a Dragonhawk or any large scale shared memory system like previously from Sun and so on. These systems are not just not mature and robust enough to offer memory as a resource. And I suspect that we need to do more.
Well, so this is what I'm talking about with conflation of terms. I think you nailed it, right? Because you called it a fabric manager. And the challenge I think that we're having with verbiage is that when CXL put out the FM API, the fabric management API, there's no logic there. It's just commands, right? It's just go do this, go do that, but there's no why behind the go do this, go do that, which is why I started using the term orchestration, just because we were calling it a fabric manager for a long time. And then it just got conflated to where like any sort of reasoning behind why fabric operations should occur is just not present in anything that's being discussed about fabric management. Fabric management is just like, what are your current stats? What's your current health? And go do this or go do that. But what you're talking about is like, oh crap, this drive just blew up and I'm wondering if I can hide it before the OS loses its mind, right? And like that's not something that's ever been present in fabric management discussions. But I think that that's something that we could do in an orchestrator discussion.
Yeah, and the Grant, this is good because you got it, and I don't have any quibble with what you said. I'll just add to what you said. I think the metaphor needs to be memory management, and we need to have clear statement of what kind of memory management style are we enabling. So let's take two examples. Okay, let's say you have a bunch of compute with their own memory resources, call them hosts for a minute, and then there is a CXL fabric that comes out of those hosts either as direct wiring or as a fabric. And on that resource, on that fabric, you have some memory resources. Okay, so you have two basic options for managing memory. One is that you fix an address space that is shared between the hosts, and you move memory in and out of there. Okay, so that addresses remain fixed. So you're maintaining a shared address space, but you're moving data in and out to make it shared versus non-shared. Okay. The other architecture is that you emphasize the formation and tear down of shared address spaces as a very fast activity. So you're respecting data gravity, which is you don't like the idea of moving data just to share it. So you optimize quote unquote fabric management so that you can set up and tear down a shared address space in reasonable SLA. where reasonable SLA might be microseconds rather than more traditional milliseconds or seconds of fabric management activities. So I think, these are very contrasting styles of building shared memory, each of which has certain implications. In one case, you will burn a lot of power moving data in and out of memory, but your setup is going to be very convenient, which is used. And I think, Grant, in the demos that you have done, if I don't misspeak, I think this is the style you have followed so far.
Qualify this for me.
Meaning the setting up a shared address space.
It was just pooling. Yeah.
Right? In fact, if you read any CXL spec documentation, I see this imprint all over the place that, translation structures are frozen based on, address space construction intent. And Siamak, you can say more because you were involved in CXL-SIG from the beginning. Isn't this the style of CXL specification that you're trying to set up a shared address space and port-based routing entries or other constructs in various places to maintain that shared address space between a bunch of hosts?
Well, you probably know the first intention of CXL was backward compatibility with the current software. So the notion that whatever you do, you still load the OS, and the OS expects to do the type of thing they used to do. Memory enumeration, come up with the ACPI tables, SRAT, SLIT, all those should still work. Now, to stitch that one, a Fabric Manager has to come in and set things up so that the OS has a little bit of an easier time. So that was the intention for CXL 2.0. CXL 3.0 came and said, okay, now beyond pooling, we'll do sharing. And from then on, I think the territory that you guys are covering starts. Said, okay, we can address people to get to this location. More than one entity can reach this location. Old methodology, legacy methodology. Now, what do we do with it? Do we declare these things as software coherent? You write once and many people read. There were a number of discussions on that. That was the beginning of concept of sharing. And then we realized that, well, it's better for hardware to do some assist. So back in validation, we need it so that some of this is done by hardware. And then that's how it grew. Is that what you were looking for?
Yeah, and I think that, let me actually copy into chat very specific language so that we are all on the same page. But the short answer to your question is yes, and it reflects completely the first of the two styles that I just posted in the chat. Okay. Because existing software, like even you might say NVLink and its technologies, are drawing from CUDA's SVA, Shared Virtual Address Space Architecture, which is in the style 1. Okay, but the downside of style 1 is, especially given what ARM have pointed out, that address spaces that are shared between a large number of hosts have resources, hardware resources, like Snoop filters and all, that scale in as a product of the amount of memory shared and the number of hosts sharing it. So you cannot have very much shared memory and still maintain some reasonable grain like page. Okay, so given the limitations of style 1 and the other downside of style 1 being that because these address spaces tend to be small, you end up moving data in and out of them to implement sharing intent. The preferred, in large data applications, the preferred construct we want is to leave data where it was allocated, sometimes on the heap, sometimes elsewhere, but set up and tear down possibly overlapping shared address spaces with a very tight SLA. I should be able to, take objects that I want to share from different places, like to implement fast collectives, and be able to do that at a command that executes very quickly across the hosts. Like, you want to do this in collective communication style. And then when you are done, everything is independent and there is no coherence anymore. Okay, that's the second style. Okay.
Yeah, okay. Pankaj, I think we will serve each other well to set expectations correctly. Earlier question you asked, is CXL for scale out or scale up? Maybe that's the key word to start exploring. And the depth or breadth of each one of those might be an issue too. The first thing that CXL wanted to do, I paraphrase that, is to first do no harm. It just needs to follow the semantics that people have done single OS. Now, you asked the question, is it scale up or scale out? In my opinion, CXL is for a scale up, but the question is how far up? How far can you go to still use the native interconnect, in this case, CXL being the native interconnect? And to what extent you can maintain hardware coherence. And when CXL 3.0 talked about 4,000 elements being in a fabric, I don't think anybody intended for all of these 4,000 elements to talk to each other at the same time. It was very clear that practically you had 16 things, 20 things, 256 things maybe, but not 4,000 all at the same time. So these are, what I'm saying, these things is in a form of setting the expectation so that people can actually take advantage of these features. The memory invalidate concept, vacuum validate concept, cannot work with 4,000 elements the way it is designed. You can share amongst several, but not many and all. So I believe if we set the expectation correctly, we can architect things and take advantage of them in a better way. On the other hand, if we say, yep, it is going to be the same thing that Ethernet has done for 1 million GPUs or CPUs, CXL is not it. And all of us will be very disappointed.
Yeah, and I think just sort of to add to that, I think that these memory management styles that you've listed are orthogonal to CXL, actually, right? Like these memory management styles come from how the host is willing to do memory management styles. It has nothing to do with the fabric and the semantics of the fabric itself. It's good that CMS highlighted what CXL is trying to be, right? Because like Gen Z tried to be everything for everybody, and it was hilarious, the aspirations of it, right? CXL is trying to be much more practical and realistic, and even with its high device count, like we know the price of silicon and the space of silicon and stuff like that, and what could reasonably be put together in a hardware coherence domain. So when you talk about like, where are we right now in general, I think we're still in the crawl phase. I think that setting up a static shared address space for stuff is the walk phase. And then once the walk phase sort of gets mature, people are going to look at it like, well, we're spending a lot of time moving stuff in and out of this static space that we set up on the fabric. It would be nice to get a little bit more fine-grained. But when you do that, the OS, the host operating system, and we're talking about Linux right now because that's the farthest down the path here, it has to be comfortable with not being the lord of the universe anymore, right? And that is a dramatic shift in how Linux memory management has worked since forever. But that has nothing to do with the memory fabric itself, right? The memory fabric just is. So I think really this is where we get into like the challenges and refinement part of the white paper is this could be this grand glorious future, but like all of these things have to be in place And they're not CXL problems, they're host OS problems and memory management style problems, which are challenges, but not necessarily Fabric challenges, right?
By the way, when is the target due date of this white paper? You guys are considering considering an year-end output in an early stage?
That is a very important question, Matthew. Thank you. When do we want to present this work?
I don't have a clear date. I think I've maybe heard some like mid this year. I think there was a discussion on the Friday meeting. Yeah, but yeah, I don't have an accurate answer. I think there were some plans to publish this white paper roughly at the same timeline as some other white papers from other subgroups. But yeah, this is part of this discussion is about we want to see what we want to cover, how much work we can commit, and who does what, and then put together a white paper.
Okay.
I see. Yeah,
Yeah,
makes sense.
because some folks were talking about trying to have it ready for the EMA, the OCP, and then obviously a lot of stuff gets presented at the Global Summit in October. I think if people wanted to work on it, you could probably put together something for April. But if you wanted to put like 7, like bullet 7, if that's something that we keep, that's like a lot.
Yeah.
Right?
Yeah, but Grant, our work is already, pending, is not published yet. So I'm just wondering, those type works, when is the due date for the publication? And
Right.
timeline, things like that, yeah.
Yeah. No, I agree. It's one of those things where it's like we're all volunteering time. But I think if this was our job, I think that'd be attainable, but we are volunteering. So I think establishing a reasonable publish date is something that we should do.
Yep.
Maybe one way to think about it, Grant, is to follow your comment, which I tried to capture in the chat, and to publish a complete solution at each phase as we achieve it. So if you think that we are at reasonable level of completion for the current phase, then we should publish a white paper now or as soon as possible to show how to carve out non-shared allocations from pools as the crawl phase solution. And it has to be complete solution with demos accompanied by white paper, or soon to be accompanied by demos. Okay. And we should do that before we move to the walk phase. But in order to not cause too much disruption for ourselves, we should have a consistent architecture in mind for how we will be looking at walk and run phases, so that the crawl solution is a clear step in that direction and not just a random data point. So we should establish an architecture direction and then publish a solution that's reasonably complete, addresses all 7 topics, but within a limited scope of crawl, for example, or walk or run.
I suggest we target, that was it, second week of April, when we are supposed to get together to present something, a portion of, maybe all or portion of this paper as a working progress, and say what we've done and what we are about to do next, and solicit help and feedback. It need not be perfect, need not be complete before it is useful. The least of it is we communicate the progress and get more people to come and join.
That's a good point. Yeah, I mean, having a skeleton together and maybe a few complete sections and then having people throw tomatoes is a good idea.
Yeah, I agree on it.
I think even an ecosystem diagram describing, whether it is NUMA libraries in the kernel or HWLock or external components from grants company or from members. What is in use? What is each component doing? What are the gaps? Something like that is also a useful thing. I think you can call it a survey or ecosystem diagram. I find those useful personally.
Looks good. I just put that ecosystem diagram under the bullet number 1.
I was trying to see if I can find an old one for you guys that might want to be updated, but give me a few seconds.
Home Jan?
Yeah.
Yeah, I have one more comment. In my personal opinion, I think that, nowadays CXL is on the chasm. So we are not sure whether CXL is alive or dead. So a clear technical trend toward the disaggregated system. So I think that at the last section, like maybe section 8, we need to think about how we can, how our effort for this type of orchestration and Fabric Manager is really important technical component linked to the future disaggregated system. Yeah, bridging to our serious perspective and insight, things like that. So yeah, I think those type of effort is very important to the future our relationship and direction. Yeah, whatever interconnect we use, yeah, CXL is very important to bridge to the future interconnect definition like optical and UA-Link or things like that. Yeah.
On this chasm,
CMS,
we
your
can
voice
maybe
is
remember.
break up. Your
Sorry,
voice is break.
Is it coming better?
Yeah, it's better. Now it's better. Yeah.
To cross the chasm, I think we should remind each other that success begets success. So let's just talk about where CXL is good for, how people are taking advantage of it. And of course, we will have challenges of doing more and more and more. Let not doing more and more and more that we haven't done yet stop us from celebrating what we've done.
Yeah. Yeah. I agree.
Do I have your permission to share an old diagram from a tutorial that Siamak, myself, and a few others did at FMS 23? I will need to screen share.
Yeah, let me stop share first.
Okay, this will only take a second, but just wanted to share with you guys what I think this could look like. So if you look, in terms of delivering CXL into the software stack, we need technologies on the data plane side to enable access using load store instruction set architecture, maybe additional instructions, compiler optimizations, and so on. These are not the purview of this group. We focus in the management and Fabric Manager type questions of control plane, virtualization, fabric management. So we are concerned about topics like reachability, ability to take physical resources and present as virtual resources, such as virtual addresses. We are concerned about failure, like erasure coding. We are concerned about dynamic and static capacities. We are concerned about discovery and configuration of memory devices and the modules that contain them. And we are interested in mechanisms that allow us to have management access, even in extreme conditions of cold start or bad failures. And that leads us to considerations of RAS. So some of these, if you see at the bottom, many data plane and scale up technologies tend to be in band, and many control plane technologies tend to be out of band. And software constructs like HMM or DevDAX or this type of things, they have evolved since I prepared this slide in 2023. But we need to either embrace this layout or whatever layout you guys want for presenting the entirety of the software stack and the technologies that we are interested in. What has happened beyond heterogeneous memory manager contribution into Linux from NVIDIA in the early days of CXL? What are the current, like Hynix and Samsung stacks that the open source both have contributions to NUMA lib and some contributions in memory allocation area? I think we need to capture in a succinct way what is the state of the art, what is it solving, what are some other black boxes that we are alluding to in our 7 sections, and present it in progressive levels of detail. I just wanted to quickly share with you guys. I think, Grant, you talk a lot about device discovery and configuration, right? Especially with respect to delivering virtual and physical address spaces, right?
Right. Yeah, and I mean it gets yeah, there's still a lot of work to do. There's parts of the implementation where things are supposed to work and they just don't. And it's just because people put together stuff and said this should probably happen. And then when the hardware actually exists and you plug it in, you put it together, like it turns out that there was a bug or it wasn't implemented completely through, or there was an expectation that a bar space would be populated and it isn't, and these are like very fine-grained things just to like attach the thing properly. Right, much less like using it in a consistent way that the spec is expecting. So yeah, I mean there are a lot of gremlins at the bottom, much less like trying to get the host and the various resource allocators to use the stuff, right? Because like when you talk about the Kubernetes kubelets, if the CXL device exists at boot time, even if it's like off, right? Like even if it shows up as a 0 capacity Newman node, it still shows up and the OS is aware of it. And so like the kubelet is aware of it. So if you grow the size of that Newman node, the kubelet is aware of it. But if you like hot plug a memory device in after the kubelet has already been started, there's no way for the kubelet to see that memory, right? So like there's gotchas at all different levels on enabling the stuff.
And right now, things like Kubernetes, the control plane and hypervisor are not even in my diagram. So what you are saying is that the diagram has moved up into the virtualization plane, where it's delivering these resources into specific technologies like Redis or Kubernetes. And
Right, exactly. And I mean, like these are things, this comes down to the basics of just like people don't expect DRAM to change once a server starts, right? There were these hard held expectations that the system is the system. Like you could potentially add a couple of things to it, but for the most part, it was flat, right? And now that isn't so. And so you're seeing how certain conventions for stuff that's now mature and widely adopted change. And it makes it challenging to integrate these new types of technologies into these existing things because stuff like Kubernetes grew up, right? It's mature and it's deployed. And now you're like, I would like to change this very core part of how you do your business. And everyone's like, no, that's not okay with us at all. Right. Yeah. So
sorry, Grant.
Mhm.
I think it suggests that there is a section somewhere between maybe 2 and 3, section 2 and section 3, that talks about what is the state of the art and what are the gaps, challenges, and opportunities. Really describing that, sort of building upon the ecosystem, an updated ecosystem diagram, saying something about the state of completeness or the quality of or maturity of software. It will be really
sure.
good,
That's
to
what I
have
thought.
that early on in the document, like between section 2 and 3 looks like a good place.
Okay. I mean, we can move 7 there. That's what I expected 7 to be.
Yeah, that's good. Yeah.
Yeah. So we could move that.
It's kind
higher.
of includes a survey, includes a survey and then lists challenges with respect to, what was surveyed.
I was thinking about lifting everybody up and talking about how cool it was and then telling them all the work instead of telling them work up front. But yeah.
Yeah.
All right. Hey, I gotta bounce. Thanks everybody. I'll catch you next time.
Yeah, thanks.
Okay. Yeah. Anything else guys want to add to the section part we have today?
Hanjan,
Yeah.
I posted my screenshot into chat, so you can capture that into the ecosystem diagram area.
Yeah. Okay. Yeah, I'll paste that to the notes.
Okay.
Okay. Thank you.
Yeah, so we should have today's meeting done, and next week we'll have XCON to present their fabric management system, and if time allows, we can keep discussing the white paper related stuff. Okay, yes, thanks everyone for joining today. Have a nice
Yep.
day.
Yep. Thank you.
Thank
Take care.
you. Bye.